So today we'll be continuing with chemical reactions. Okay, so in terms of organic chemistry, these are chemical reactions that are going to affect to do with them. Oxidation, this is when carbohydrates, especially alkane, is going to react with oxygen. You have substitution reaction, addition reaction, and elimination reaction. So the first one we're going to look at is oxidation reaction, which is when your carbohydrate, specifically alkane, reacts with oxygen. So we can see here we will have an alkane reacting with excess oxygen. So it's going to be in excess in terms of the number of moles required. The reason why we put it in excess is so that the alkanes can react, right? All of the alkanes can react, and not only that, we want to produce carbon monoxide instead of carbon dioxide because carbon monoxide is more dangerous than carbon dioxide. So we're going to give it excess oxygen, and we're going to produce carbon dioxide plus water and energy. A good example of this would be burning wood. So yeah, we have the substitution reaction. So substitution reactions are only going to take place when we have saturated compounds. So saturated compounds are the compounds where we only have single bonds between our carbons. So this means things such as alkanes, alcohol, halogens. All of these are not saturated. Therefore, they can go through substitution. And they're going to produce a product that is still going to be substituted because all we're going to do is take one atom and replace it with another. These reactions are slow. They are not spontaneous. This means that they require energy. So we're going to either give it heat or sunlight in order for these reactions to take place. So let's look at the two substitution reactions that we have. The first one is halogenation. From the name alone, we can tell that we are producing a halogen. So halogenation just means generating. As we said, they are non-spontaneous, so they are going to require heat in order for them to work. So you would see that the reaction conditions is that they require sunlight or heat dependent. Now, the first one, we are taking an alkane and we're going to substitute in a halogen so that we can get a haloalkane and a hydrogen halide. This is the hydrogen halide. The halide, or in this case, the halide, the halogen is going to be dependent on what halogen you have here. So let's have an example. Let us say that you had ethane and you reacted ethane with a halogen. In this case, let's use chlorine in the presence of heat. Then you would produce a haloalkane and a halogen halide. So this is your sulfuric acid. And with regards to this, we know how to name. We're going to make that carbon number 1, carbon number 2. So that means we would have 1 chloro. The chain is made up of 2 carbons. So that's going to be ethane. Then we have your hydrolysis. The word hydro should already indicate that there's water involved, right? So there's 2 ways you can have hydrolysis. The first one is where we actually have water involved. We're going to react a haloalkane with water to produce an alcohol and a halogen halide. Or you could take a haloalkane, react with a base, right? A strong base. So sodium hydroxide is a strong base, and this strong base needs to be dilute, and it would form alcohol and a salt. So example of this, let's use this halogen halide that we had from the other reaction. So if we go via hydrolysis, this is now adding water. We would then replace the halogen with a hydroxide. Now, because water is made up of a hydroxide and a halogen, we know that that hydroxide is going to go there. Therefore, that halogen is going to react with that chlorine to give us hydrogen chloride. And for the next one, where we reacted with a strong base that is dilute, make sure that it is dilute. If it's not dilute, another reaction would take place instead of this one here. So we would then produce alcohol again and a salt. So the salt is going to be dependent on the base we use in terms of the metal and that non-metal over there to give us, the plus is already there, sodium chloride. And those are our two substitution reactions. We are moving on to addition reactions. Now, with regards to the addition reactions, they are as they say. They are there to add to whatever we have. Now, in order for us to be able to add, we need to have such unsaturated compounds. So when we're talking about unsaturated compounds, we're talking about alkenes and alkynes. But for grade 12, we only focus on alkenes. These are the ones with the double bond. And what they're going to form is that they're going to form saturated compounds. These reactions are faster and spontaneous, so they do not require heat, but some of them require catalysts. The first one we have is hydrogenation. Again, the word genation just means to generate. What we focus on is the word hydro. Hydro stands for hydrogen. Okay? So, hydra, please note the difference between hydro and hydro and hydrate. Hydrate is for water, hydro is for hydrogen. So, for hydrogenation, implying now we are going to add hydrogen, we will take an alkene and form an alkane. Now, it needs to be in the presence of a catalyst. A catalyst is a compound that does not take place in the reaction, but speeds up the rate of the reaction. So the catalyst can either be platinum, lead, or nickel. So an example here, say we had anything and we reacted it with water in the presence of platinum, then we would produce anything. The next one is halogenation. So we are producing a halogen or a haloalkane. In this case, we do not require a catalyst, so we're going to have a double substitution. Right? It's a haloalkane, but unlike the double it is a haloalkane, but unlike our hydrolysis, our halogenation, the first one that we had, we are adding a single substituent, whereas here we're going to add double. So again, let's take that ethane and we're going to react it with chlorine. Both the chlorines are going to be substituted onto the carbons. So this is a double substitution of halogen, whereas the first one in terms of substitution is a single substitution. Then we have hydro, halo. So now we can actually have a single substitution if we make it react with a hydrogen in the presence. So that's why we use a hydrogen halide, so that when we substitute, we now get a single substitution instead of a double substitution of our halogen. So the compound would look like this, where the extra hydrogen and halogen comes from the hydrogen halide. The last one we have for addition is hydration. So hydration, we are adding water to our alkane to turn it into an alcohol, and it must be in the presence of a catalyst, and the catalyst here is sulfuric acid, and it needs to be concentrated. So what's going to happen is that alkene of ours, is going to react with water. Let's remember that water is made up of a hydroxide and a hydrogen. So therefore, we would have that hydrogen here, that hydroxide there, and we will just have the normal hydrogens that we had before. So now we're going to move on to the elimination reaction. For the elimination reaction, this is going to occur when we take a saturated molecule and we turn it into, sometimes it's saturated and unsaturated or just saturated. Depends on what we're doing. Or sometimes we can just go in reverse when we take something that is saturated and take it back to unsaturated. Hope it makes sense. It depends on the elimination reaction as to what is happening. So the first one, which is cracking, is where we take something that is saturated and we turn it into two products, one that is saturated and one that is not saturated. Right. And this needs to be done in the presence of a catalyst if we're going to be using, there's two, sorry. That doesn't have to be in the presence of a catalyst. There's two. It's either you're going to do catalytic cracking or you're going to do thermal cracking. Now, for thermal cracking, you're going to use high temperatures and low pressures. And for when you use a catalyst, you're going to use low temperatures and you're going to have high pressure. So you're taking a very long chain and you're cutting it into chops, cutting it up. Then here we have where you go from a saturated to an unsaturated. The first one is the hydrogenation. Just by the hydro, we know we are removing hydrogen. So this is going to happen in the presence of a catalyst, which is going to be lit for us. So we have the alkane turning it into an alkene. It's just the reverse of the hydrogenation. Then we have dehydrohalogenation. So we are now removing a halogen and a hydrogen. Very important, we are using concentrated sodium hydroxide as our catalyst. We understand that if we were using a dilute one, then it would go through hydrolysis, right? Not through elimination. So if you use concentrated, you're removing. If you use dilute, someone iPad, I would like if you don't touch the screen, sorry, because you're moving our papers here. I'll try next time not to allow movement. I apologize. But notice the difference. Both of them start off with an haloalkane. If you use diluted, you would get alcohol. But if you use concentrated, then you get an alkene. The last one we have is dehydration. This is the removing of water. So then we would get alcohol, remove that water, and turn it back into alkane. This is happening in the presence of concentrated sulfuric acid and heat. That is the difference between that reaction over there and this one over here. This one over here is spontaneous, does not require heat. When you put in heat, then you're going to go through elimination instead of addition. So just be aware of the differences. Then we have one last reaction to talk about, which is reactions of esters. So we are able to produce an ester from an alcohol and a carboxylic acid, and this process is known as esterification. And in order for this process to take place, we need to have a catalyst in place, and that catalyst is going to be a concentrated sulfuric acid. So in this case, we're going to have an alcohol that has a hydroxide group, and we're going to have a carboxylic acid that has a hydroxide group. So what we're going to do is that we're going to take the hydroxide from carboxylic acid, and we're only going to take the hydrogen from the alcohol, so that we can put these two together to make water. And once these two are removed, that oxygen will then go ahead and connect to this carbon there, forming an ester. Now, the part that comes from the alcohol is going to get a line when we are naming, and the part that comes from the ester is going to get an anoate when we are naming. We did go over naming yesterday. I uploaded the video, so if you want to go through that, you can do that. And yeah, yesterday was the first part of our organic chemistry. So now we're going to move